You know how sometimes you learn a basic rule in physics and it just feels wrong? Like it doesn't quite match what you see in the world around you. Well, today we're going to tackle one of those exact laws, a law that has had people scratching their heads for centuries. We're going to figure out the real reason things stop moving.
Okay, so here's the heart of the puzzle. You've probably heard of Newton's first law of motion, right? An object in motion stays in motion. Simple enough. But think about it. You roll a ball, it stops. You slide a book across the table, it stops. You stop pedaling your bike, you eventually stop. So, what gives? This is exactly why that famous law can feel so wrong.
So we're stuck in this kind of tug of war, aren't we? On one side, you have your own everyday experience, what your eyes are telling you is true, and on the other, you've got this pillar of physics. How can both of these things possibly be right at the same time?
And hey, if you're sitting there feeling a little skeptical about this whole stays in motion thing, you are in excellent company. I mean, this isn't a new problem. For literally thousands of years, people looked at the world and came to what seemed like a totally logical conclusion. If you want to keep something moving, well, you've got to keep pushing it.
The guy who really put this common sense idea on the map was the ancient Greek philosopher Aristotle. And his explanation for how things move was just so intuitive, it made so much sense, that it pretty much ruled scientific thinking for nearly 2,000 years.
Aristotle's whole theory just clicks with our gut feeling, you know? He basically said that the natural state for everything is just to be still, to be at rest. A rock, for instance, it wants to be on the ground, not zipping through the air. So in his world, motion is this weird, unnatural thing, a temporary state that you have to constantly force to happen.
I mean, it's so simple, right? To move something, you got to push it. When you stop pushing, it stops. And this fits perfectly with, well, everything we do. Pushing a shopping cart, kicking a ball, you name it. It feels right. But here's the thing. It's totally, completely wrong.
So who was the person who started to pull the thread on this ancient error? That would be Galileo Galilei. What made him different was that he didn't just accept what he saw. No, he used this incredibly powerful tool to dig deeper, the thought experiment.
And Galileo's huge breakthrough was this. He realized that the world we live in isn't some perfect, clean system. He was the one who pointed out these hidden forces that are always at play. Things like friction between surfaces and air resistance. These, he said, are the real culprits. They're the reason everything is always trying to grind to a halt.
Okay, so picture Galileo's thought experiment. Step 1. Imagine you push a block of wood across a really rough carpet. It stops almost instantly, right? Okay. Step 2. Now push that same block with the same amount of force, but this time across a super smooth sheet of ice. It's going to slide way further. So here's the final leap. What if you could get rid of friction completely? What then? Well, in that perfect ideal world, the block wouldn't slow down at all. It would just keep going forever.
And that right there is a massive shift in thinking. See, Aristotle believed that force is what you need to keep something moving, to sustain motion. But what Galileo figured out, and Newton later perfected, is that a force is only needed to change motion. An object is totally fine just coasting along at a steady speed in a straight line forever. You only need to apply a force if you want to speed it up, slow it down, or change its direction.
So you can think of it like this. Galileo did all the heavy lifting, he laid the conceptual groundwork, and then Sir Isaac Newton came along and took that incredible insight and turned it into a formal, rock-solid law, one of the absolute cornerstones of physics.
And here it is, in all its glory, the law of inertia. Honestly, the easiest way to think about it is that objects are just lazy. They want to keep doing whatever they're already doing. If they're sitting still, they want to stay still. If they're moving, they want to keep moving. The only thing that changes that is an outside force messing with them. So, that ball that stopped rolling, the reason it stopped is because friction was that outside force pushing back on it.
And it's really important to see how this all unfolded, right? Science isn't usually about one person having a eureka moment out of nowhere. It's a progression. Galileo had the guts to challenge an idea that had been around for 2 millennia. And then Newton stood on his shoulders, basically, and built on that idea, giving it mathematical rigor and making it the very first of his 3 iconic laws of motion.
Okay, so why does any of this matter? Why go through all the trouble of replacing a simple, common sense idea with something a bit more complicated? Well, because getting this one idea right was the key that unlocked the door to understanding pretty much everything else about how our universe actually works.
All right, so let's boil this all down. What's the big takeaway here?
First off, our gut intuition is awesome for day-to-day life. But when it comes to physics, it can seriously fool us because it ignores all those hidden forces like friction. Second, and this is the big one, motion is just as natural as being still. The thing that needs a cause isn't the motion itself, but any change in that motion. And finally, you have to realize, without this law, we'd have nothing. No understanding of gravity, no clue about planetary orbits, no way to send a rover to Mars. It all starts here.
And this whole thing leaves us with a really cool question to chew on. We've just established that things want to move in a straight line unless a force gets in the way. But planets don't move in straight lines, do they? They travel in these huge looping orbits. So what's the invisible force that's constantly pulling on them, constantly changing their direction, and stopping them from just flying off into the blackness of space? Well, that's a puzzle for another day.